Okay, so the variance mainly suffering from the units, that is the first one. So because if you are giving one unit and it is taking some other unit kind of aspect, and so as to reduce that thing, we are having the standard deviation. So within the same units, you can perform the activities. This is one kind of thing we have seen. And if you observe, friends, here, another important aspect I am going to talk in this session is the discussion about variance and as well as the covariance kind of aspects. Because, you know, at the moment, if I'm talking about the statistical measures and all, this is the first level actually. So whatever the central tendencies we have seen, and as well as the measures of dispersion, all those aspects are which are really helping us to understand the behavior of the data. But apart from that, a little advanced we are making, that is what you call the covariance aspect. So if I'm talking about covariance, so what do you mean by this covariance? Generally, friends, if I'm referencing this covariance, this is a measure, okay, how the changes in one variable also are associated with the changes in second variable. Because so far we have seen some kind of the data and how the data is giving us the mean value, median, and mode. And thereafter we have seen some kind of the aspects, you know, like the variance and standard deviation kind of things. And they either they work with the group of values and they are giving some kind of the commonalities. Sometimes, you know, friend, there is a chance of observing whether the any identified variables are correlated or not. And if you are referencing the two variables, whether they are associated or not. So if I'm referencing the variable, I mean, some variables are there in the corresponding data. And if I want to observe the covariance, variance is just give that how a single variable varies. But whereas if I'm talking about the covariance, it is giving how two variables are distinguishing. Let me pull some data for you. So just it is helping us to understand what exactly the covariance. Have a look on this, friends. Just it is a kind of understanding where you can observe, because from this particular point of view, we are entering into the genre of our machine learning, because these things are directly correlated, is having direct impact on our models also. Directly we are making use of these kind of the conventions so as to understand the process and procedure related to these aspects. Okay, now covariance is a measure how changes in one variable are associated with the changes in another variable or second variable. Suppose if I'm taking x1, x2, and so on xn, and if I want to observe x1 versus x2, what kind of association I'm having, or the kind of the relativity between these two kind of the variables, then I can bank on this covariance, and which measures the degree to which two variables are linearly associated. Up to what extent these variables are associated, you can specify the measures of the degree. And it is similar to the variance, but where variance tells you how a single variable varies, but covariance tells you how two variables vary together. Now it is fair understanding, no doubt and nothing. Because if I am talking about the variance, friends, what it does, just it is taking some kind of the group of values and it is giving some kind of the outcome. So how one variable is distinct with the entire group. Whereas covariance is not like that, friend. Just you can observe variable 1 and as well as variable 2. Then finally, you can say how one variable is associated with another variable. Okay, this is a kind of the association. Now you tell me, friends, association in the sense, generally, if I'm comparing two variables, maybe I can give some example. Skill level of Suresh, because Suresh and Venkat both were attended for the interview, and skill level, kind of experience, and as well as the attitude, all the things we're considering. And I am assume that I am one of the panel member who interviewed all the members, and I have shortlisted Suresh and Venkat finally. So if I am referencing this skill set, experience, and as well as the attitude kind of the aspects, so just there is a kind of correlation. Maybe after shortlisting and after recruiting, you can see more or less the same kind of the potentiality. Like, so in the project, or else if you observe the way the understanding of the subject, the hold or command, okay, I can say these kind of things can be very much helpful to conclude related to the covariance. Okay, but maybe you are having some doubt. So it is a typical scenario where I can specify the usage of the variance kind of aspect, so that I can give the group wise variance to a particular variable. But how do we narrate the variance related to two variables? Now have a look on this, friends. What is your understanding from this? Covariance of two variables. Okay, friends, here y is not our y. Our y in the sense y is equal to this thing is there, na? Beta 1 x1, beta 2 x2, not this x or this y. These are all typical variables. Maybe you feel this as x1, x2 kind of thing. Okay, that is what generally in the machine learning landscape, x and y are having some dedicated meaning or context. That's what we always avoid the direct usage. But in case of the statistics, it is okay. But whereas in terms of if you are explaining your x and y values in terms of the machine learning, definitely you should see the context. Okay. Now, just can someone explain me what exactly this equation is saying, friends? It is looking like our variance also. What exactly it is doing?
You are taking the variable x with the mean of the variable x,
Very
and
good.
the variable y with the mean of a variable y.
Very
You're
good.
minusing by n-1.
Very good. Each variable.
But one question, Uma, here. How both xi and yi are they directly proportional to each other? I don't think so. I don't know.
Yeah. Okay. That is always.
Suppose if y is really doing a mischief, then how x is going to respond to that?
Yeah. Maybe this is the answer for your question.
You have all ready-made answers here. Come on.
No. My goodness, you are
You
asking.
know very well that Suresh is going to ask.
No, not like that, Suresh. Because see, why I am happy with you guys is you always ask the doubt which is connected to the next topic I'm about to tell. That as a mentor, that is more than happy, na, to me. Okay, if it is something means then I also wonder and I will get answers for you. But this is absolutely, it shows that we are in sync. That's what my happiness. Okay, whatever the things I'm covering, I'm about to cover. Definitely, you ask the doubt from that genre only.
He's giving a see. It is directly proportional.
That's
it. It will increase or decrease. Whether the covariance is a positive.
Correct. Have a look on this, friends. As per our friend asking, he is asking that how this xi and yi are going to behave after completion of my covariance calculation. It's a simple thing. If both variables tend to increase or decrease together, have a look on it. It will be tricky. Together, then covariance is positive. That means x value is minus 10, minus 20, minus 30, and minus 40. Y is also going in the same direction. Maybe increase or decrease. Okay, in the same proportion, then the covariance is positive. And if one variable tend to increase as the other one decreases, the covariance is negative. That means if x is traveling in negative direction, it is traveling in positive direction, then there is a negative correlation. This is a positive correlation. Now, the most interestingly, both variables are independent. That means how can you give the example, friends? Can someone help me to give the third example? I mean, to explain the third context, because first two context we are having a fair understanding. Suppose if any value is increasing or decreasing, then covariance is positive between those two. Like x is increasing, y is also. X is
so if you have, suppose the same example of what you have taken, Suresh and Venkat. Last, you have chosen both because they have a common things. which I mean the standard considerations you have taken the parameters.
Correct.
That if they are both different, like suppose now you can take that Suresh has age factor and Venkat doesn't have an age factor. That is also considerable. Then you may not choose Suresh. You may choose Venkat because most of the companies chooses age factor.
Young chap. Young chap, sir. Okay. So,
Obviously, I mean that's happening now.
Yeah, Suresh, can I take that as independent? Can you confirm your understanding, because because I am little bit worrying about.
Okay. If you can also say that there is some speciality which Suresh doesn't have and Venkat has.
Yeah. Age. That's what my question here is age.
Yeah. You are correct. You are correct, because this is also a common factor.
Yes.
Age is a common factor. So there might be something. So suppose like a skill which is a unique skill which a Venkat has and Suresh doesn't have.
Excellent. That's all, guys. See, independence may always not harm to us, friends. I will show you that by the end of the session. You are going to wonder if two variables are strongly dependent, or if they are changing with one based on another. And long back also I have given one example. If you remember, Suresh is the guy who is motivating all the 10 members, and if Suresh is moving out of the office or out of the company, these 10 members are also blindly follows him. See, that is a dependency actually. Like that in the dependency is a kind of dependency. And I'll give you a technical reason of today. However, we are going to correlate all the statistics we have discussed in the real-time applicability of our machine learning, which is having a great potentiality and scope of concluding these kind of descriptive statistics, because I have to start the probabilities and distribution functions also. This week my plan is to end up the discussion with the stats, and from next week onwards just will jump into the machine learning algorithm implementation. Okay, so that is what the reason. Just will see all the practicalities related to the stat models and as well as our expectations. Okay, now if you refer the kind of positive correlation as well as the negative, observe here, friends. So just if I'm referencing the orientation, okay, so just a diagrammatical representation of the above equation. Rather, I can say rather than giving the numbers, I'm trying to explain this aspect with the help of the image. Okay, so large negative covariance. What do you mean by covariance, friends? Basically, covariance gives the rate of change of one variable when compared with the another variable. So what do you mean by positive covariance, friends? If one variable is positively moving,
increasing, other variable is also increasing.
This is a positive correlation. Okay, whereas
X to Y,
X to Y, maybe that is very commonalities.
It's a straight graph. It's a simple graph, like
simple graph, and you can easily figure out. Yes, they are having correlation. But if you talk about the first diagram, friends, here is see, while X is increasing, Y is negatively impacting that. This is a
no. Actually, you can't say that also. Here also X is decreasing and Y is decreasing. Now, if you
this is
take X and Y axis.
Not these are all not axis actually. The relationship this is axis. If I'm saying, if you see here, you are right, because axis, if I'm saying, somehow it is also related. But what we are doing here, after completion of our observation, we are presenting the way of relativity between those two variables. So in that case, friends, it is, though they are related, negatively correlated. Okay, they are negatively correlated. But what about
negatively correlated? Yes.
What about this? This friend, this is what can I?
The X and Y are behaving differently.
There is no correlation.
There is no correlation.
Maybe there is no common point, or there is no commonality while taking the covariance kind of things. Okay. Now, what is the problem with covariance, friends? You can easily
the problem is like there should be a uniformity between both.
Excellent. Here, see, the first point is X and Y
should match each other.
must have same kind of thing. What is the other problem, friends? If you could see the way we are computing the equation, you can easily tell, friends. Again, x and y, we are expecting to establish a covariance kind of aspect.
That same kind of units or same type of
units we won't get, because x and y are individual units, but we are multiplying. That is one issue. Very good, Venkat. Any other units issue? One important thing you can say by seeing
n-1 is considered.
outliers.
Is there any effect of outlier? Yeah, of course. Mean, if it is doing,
The mean is there here. Outliers will
definitely impact. And one more thing, friends, can I expect a boundary between the x and y while calculating the covariance?
Boundary in the sense? What
Boundary
exactly you mean?
Between -1 to 1 or 0 to 1, like that range, can I expect?
Yes,
range
will be in that
range between x and y.
I mean, suppose if I am calculating the covariance of x comma y, can I expect the value between -1 to 1, or it is like 100, 200, maybe 150? Is there any boundary between the values, friends, here? What we are expecting or what we are computing? Because see, only we can say from this diagram also whether this is negatively correlated or positively correlated, or whether they are correlated or correlation is there or not, I can say. But can I say these values are between -1 to 1 or 0 to 1? Any such kind of benefit are we going to get, friends?
I don't think so.
Don't think so, because reason is what we are doing here. Suppose 5, 3, 2, like that we are having three values, and here I am having 10, 6, 4. Can someone quickly calculate what is the covariance of these two? I mean 5, 2, 5, 10, 3, 6, 2, 4. Simply we have to calculate 5 minus mean of this thing, some whatever the mean we will getting, and yi means some 10 I have to take minus mean value. Like that we need to calculate 6. 5 minus 6 minus 1, 5, because mean of all the things. Okay, so definitely it is going to give some value, 20 sometime, 25 sometime, 30 or 35 or 18, like that. And we are not going to get any boundary values, friends, because how they are varying, because they are not going to vary between -1 to 1 or something like that. Okay, so this is how you can refer. There is no boundary kind of aspect, and units are the main issues. And xy, as our friend told, they should have the same kind of the range or units. Now you observe here, friend, the problem. If I am making use of variance, what is the problem with variance, friends? What is the problem with variance? Just now we have seen, our Venkat has given some insights. Variance is nothing but how a variable is distinct or behaving differently when compared with our group of values. Similarly, what we have done, friends, to solve the variance issue, what is the unit, what is the calculation we are having in the statistics?
standard deviation.
Standard deviation.
Standard deviation. Similarly, here I have taken the usage of the covariance, but I have not satisfied, because you observe here, friends, in most of our machine learning algorithms, we need to have the understanding of how the values are tagged, how the values are associated. So in that particular case, with the units issue or with the boundary issues, I cannot manage all these kind of the conventions. So our next discussion is correlation. Okay, so what do you mean by correlation, friends? How can I say?
How they are related to each other.
How they are related to each other. Now you may ask me, so is there any relationship between correlation and as well as the covariance? Yes. Observe here the corresponding formula, friends. First we have to calculate the covariance, and thereafter we need to divide that particular value with the standard deviation of x and standard deviation of y, which is giving the correlation. Okay, now this particular correlation is having some kind of the benefits, friends. Okay, now if I am making you to understand this particular diagram, just have a look on this. Very important analogy, friends. Without text, just we are trying to understand this particular aspect with the diagrammatical representation. Venkat, can you focus on this and can you give some insight? Just to observe that. So we are having the covariance with us, and we are having standard deviation of x and y. So this is rho or kind of thing, which is a correlation. That is okay. And now if you are referencing this diagram, it is trying to say some story to us, friend. That we have to observe. Just to observe that, what is that story?
See, if it is 0, that means they are not at all linked to each other. There is a weak correlation. If it is strong, either on -1, they are opposite. The other one, positive, means they are positively drifting. Means weak correlation or zero correlation means they are not at all related to each other.
Okay, 0 means no relation. Maybe if it is negative also.
Minus means one is growing, one is like on the other way. If one is reducing, the other one will be like increasing. That kind of.
Other is reducing, another also
Increasing, I think. No, minus means.
no. See, if minus 0.5, minus 0.6, minus 0.7, obviously your y also moving in the same direction.
In the same way.
Then only I can say that is having the correlation. Now see, Venkat, here if your x value is moving negatively, if y value is moving positively, there is a weak correlation. Okay, so and one more important thing at this moment,
value nice.
Value it is positive actually. So and from this particular point of view, this is moving right side actually. Even if you are
value, this side, that side.
That's
if it goes left side, goes negative, goes this side.
This side, okay, na? This is what we are talking about. Okay, this is the axis, and generally our convention is we don't work with this negative axis. Na? That's what we are saying is just our interest is x-axis only. Okay, how the x values are going positively and how these values are going negatively. We generally won't prefer to work with the y. Our understanding is how these particular things are moving ahead with positive or negative kind of direction. Now you may ask me this question. You have introduced us the covariance. Now we are telling about the correlation also. Can you clear the differentiation? Can someone help me, friends, to understand what is the distinction between correlation and covariance? Because let me show you the equation which is covariance is banking on. And whereas if I am talking about the correlation, this is the equation actually. Now, one more thing we are claiming that our covariance is suffering with units, and at the same time it is not having any boundaries. Okay, so if you are referencing these particular points, friends, obviously you can observe, okay, what exactly the reference of correlation and as well as the covariance. Okay, so have a look on this, friends.
See, when you consider covariance, covariance is directly on your x and y relationship. It's only based on the x and y. How x is related to y, and how both are coming. But here in correlation, also you have the standard deviation in the bottom.
Okay.
So that will also put an effect on the coefficient of the correlation.
Definitely. Yeah. Now, one more thing, if you observe, Suresh, basically as your from your point of view, if you are saying the covariance and as well as the correlation, it is giving covariance also giving the positive or negative kind of thing. Correlation is also giving the positive or negative correlation. Now, if you observe, friends, here, covariance is not bounded by the values, whereas correlation is bounded by the values. because it strictly follows the ranges between -1 to 1. That is one of the advantage, so that we can easily accumulate and we can easily observe in what way it is moving ahead. Another important thing is correlation doesn't have any units, friends. Basically, see, if you observe the intent of this diagram and as well as this thing, actually, if I'm computing this correlation value, I won't get any units. By if I am telling this particular equation, if I want to implement covariance of xy as mean is involved and all those things, definitely I'm having the units. But whereas after computing this covariance, again, we are applying the standard deviation kind of the aspect, so that there is no unit reference here. So basically, correlation is not having any units, but whereas if you are referencing the covariance, definitely it is having units, which is causing some kind of, if I'm using as earlier examples, centimeters, I will be getting centimeter square. And if I'm using inches, we will be getting the inches square, like how we have observed in the variance and as well as the standard deviation. Now, most importantly, strength and direction. What do you mean by strength and direction, friends? Can someone help me on this?
How strongly they are related. And
Lakshmi?
how strongly they are bonded.
No, all are facing the same 3D effect of her voice, or I'm only the one?
Facing the same.
Same, oh, is that? Maybe I removed my headset and I'm thinking about what happened to my ears or like that. Lakshmi, just to check your side, maybe. Okay, no problem. Then I will take just to compare these two, friends. This is of course our covariance graphical representation. This is our correlation. Now you see here, even our in the discussion we had a confusion. Yeah, this is also correlated, like that. But whereas here there is no such kind of the confusion. It is clearly saying the direction also. This direction, if you see, is a positively raised graph. Whereas if you see this direction, it is a decreasing graph, okay, in the negative mode. So both strength and as well as the direction are possible with respect to the correlation. But whereas our covariance, there is no kind of value, or there is no kind of relativity, like it is not showing any strength, or it is not going to help us any understanding of the direction and as well as the strength of the corresponding aspect. Okay, so this is how you need to observe the correlation and as well as the covariance. But only the thing is, friends, directly you may not get the understanding of this equation and all. But whereas just in case of Python and R, we are having a direct.
Yeah, really, it's getting difficult to understand the correlation part of. It is going with a vector type of
exactly.
Direction, but how the direction is considering, that's a real this thing, because in this one covariance, it is straightforward. It is the distance, how it is moving, you can see it. Yeah. But the correlation is really getting confused.
No problem. I think I'll remove that confusion. You see here. Yeah. If you observe. Now have a look on this. Still. We can have a
close to 0, it means that there is no relationship between the variables. Positive means that one variable gets larger than the next variable. R is negative means that
1 minute, friends. Just you can correlate this thing with the diagram so that you can easily observe. Yeah. If R is 0, then it is
a correlation.
There is no relation. Now, if R is positive, that means maybe some 0.4 or 0.5. It means that as one variable gets larger, the other gets larger. So maybe X value is increasing, your Y is also increasing. Whereas if R is negative, maybe I'm getting some negative value. What is the value, friends? This is nothing but correlation only. R value is nothing but the correlation formula. That value directly, if I am getting And one more thing, I should get the value either -1 or 0 in between these. Okay, in between -1 and 0, I will be getting the values. Now, if you are seeing this particular thing 0.4, as I am having the positive value, it is a positive correlation. That means if R is positive, that means my correlation value is positive. It means that as one variable gets larger, the other gets larger. Whereas if R is negative, that means if I am getting the correlation as negative, it means that as one gets larger, the other gets smaller, often called as inverse correlation. This is nothing but the inverse correlation. Yeah.
It is a thumb rule that definitely if your R is a negative, when you get a correlation negative, that means one will be larger and one will be smaller.
Definitely.
Is it a thumb rule or you need to consider like that?
Not a thumb rule, actually. It is a fact. Because see, R is a processed data. Na? If you see R value, what is the
data? Yes.
R is equal to nothing but covariance by standard deviation, some formula. That means already we have emphasized on XY values and we are working on R value as 0, R value as positive, R value as negative. Now you see, friends, maybe if you are not seeing those XY values also, you tell me this point, if your R is positive, then what is your conclusion? If your R is positive, what is your conclusion? Between this X and Y, there is a positive correlation. Now you analyze, oh, that means if any value, if one value is increasing, other value is also increasing. If my R is negative, that means whatever the value I have computed as a part of my correlation, if something happened to this particular one variable and negatively impacting the other variable, this is the.
But you see here, Uma, when he is saying that, okay. When it is positive, there is a direct relationship. One gets larger, other gets larger.
That's simple.
When it is negative, one gets larger, other gets smaller. So it is they are not dependent. They are independent. They are.
No, they are dependent, but in the different direction.
Inverse correlation. Inverse correlation.
Can we go back to the previous one? We can this
example. Okay. Now
one is directly proportional, one is inversely proportional.
If it is minus, that means one is growing, other one is decreasing. The -1 thing.
See, yeah, exactly. If you are referencing this one, I have explained in which one? Correlation or covariance?
Actually, this is not giving a correct picture here.
No. Yeah. See, one thing here. See, simple thing, friends. Covariance and correlation, both the things are working for the same. No doubt about that. Maybe in covariance or correlation, if your covariance is positive, if your covariance is negative, or if your covariance 0, then what we are understanding, there is a strength in the both of the variables. There is a negative covariance and there is a 0 covariance. Similarly, in case of the correlation also, what I am seeing, friends, if I am making use of, if I am making use of the positive value, there is a positive correlation. Yes, you are right. Whereas I will do this way, because if you are talking about the R value, don't get confused with R value and as well as the between minus and positive values, friends. You observe here, R value is different. Don't compare R value with the diagram. Diagram is different. Maybe if you see, if I am getting R value as a negative, but still there is a negative correlation. That means, let me explain this way. My X value is -10, -20, -30. This is -20, -20, -40. Now, whether these are all correlated or not, friends, how can you say? And I'm asking this question also. 10, 20, 30, 20, 20, 40. Now, can someone help me to understand what is the difference between these two?
Negative correlation, positive.
Negative correlation and positive, that's all. But see, maybe if I'm getting R value at 0.4 here, I may get R value as 0.4 here. Don't get confused with your R value and don't tag that R value with your understanding of this weak or strong relation. Just to be cautious, friends. Just to be
That is
cautious.
confusing actually.
This Venkat guy asked me to pull the diagram again.
Sorry. But we have done
He's
all
the one. He's the one who is dragging us to talk about this again. But however, it is good to ask. It is good to ask. Well, let me clarify the point, because those questions must be, because rather at later point of time, if you are getting ambiguity, your entire understanding is in collapse mode, friends. Okay, just to observe here, XY correlation. If I am talking, as mentioned earlier, maybe there is a negative correlation in the sense there is a R value must be somewhat maybe 0.4 or something. And in case of the positive also, friends, observe here, in case of the positive also, what we are seeing, friends, in case of positive also, I may get R value as 0.4. Evidence is, you see here, what is the formula here, friends? Covariance of XY by standard deviation of X into standard deviation of Y. Now you observe what is the formula for covariance. Is there any possibility of getting negative here, friends? Negative value can I get? Because X is my individual value, X bar is my mean value.
No, we cannot.
We cannot. Okay, we cannot get the covariance as a negative value, but we are claiming that individual values, friends, you need to be in a position that we are taking the individual value and mean value. We are taking the individual value and as well as the correlation value. Don't get confused with your R value is nothing but your group value, friends. R value is your group value, and inside we are having the XY values. It is like, though I am comparing Suresh and as well as Venkat for a recruitment process, same example, Suresh and as well as Venkat, and I am finally observing that is a positive correlation. That means if I am taking Suresh, I can make one wing under Suresh, and I can make Venkat as another wing 1 and as well as wing 2. Whereas if I recruit Yogesh, maybe Yogesh is having a different skill set. I cannot put Yogesh under Suresh or Venkat. Maybe I can pull him to another wing. So that means this is creating another avenue. We are comparing Suresh, Venkat, and as well as Yogesh individually. That means how we are comparing between X and Y values. Whereas as a totality, like, maybe if my CEO is asking about, hey, this weekend, how many members we have recruited? I can say 3 members. That is a total. That is a total representation of the R. Whereas if he is asking me in data science wing, how many members, and in Hadoop wing, how many members, then I can individually specify that. As a total, I can say these 3 members I have been recruited. Whereas if you are referencing in data science these guys, and in Hadoop, that only one guy I have recruited. So here also, maybe I'm talking about my X and Y values based on this particular R value. But R value is positive or negative, whatever, but still there is a correlation between those two, positive, negative, or no correlation. But as far as this particular diagram you consider, this one, this is nothing but, don't worry about your weak or a strong motivation of these particular values. Rather, what we are doing, definitely either the negative values are impacting each other. That means X value is negatively growing and Y value is also negatively growing as per that X value. Then I can say this is a negative correlation. Of course, correlation is there. And here also, if one value is positively raising, obviously, as a follower, other value is also raising. Definitely, there is a correlation. Don't feel that negative correlation in the sense one is positively raising and another is negatively raising. No, friends. Okay, don't go to that side. Only it is decided by your R value. If R value is positive, then I can say is a positive correlation. If R value is negative, that means those two variables are negatively contributing. If one value is raising, another value is decreasing. No correlation means there is not at all. R value is completely 0. So there is no, we cannot establish any kind of the relation related to that kind of the aspect. Okay, but don't think much, friends. Okay, just to understand that correlation and covariance are used to observe the relativity between the two variables. And directly we are having the formula, I mean the method for the correlation in Python and R. Okay, we don't want to get any statistical kind of the formality or formulation. Simply you can give COR of your COR of x comma y. It will give simply value. Maybe as I am talking about the correlation, it should be -1 and as well as the 1. If I am getting 0.5, then what is your analogy, friends? If I am getting the value 0.5, that means our value is 0.5. My Python has given the value as 0.5. Then which kind of the relation they are having, x, y?
When x is growing, y is growing.
Positive. Suppose if I am getting minus 0.78 like this, negative correlation.
When x is growing, y is decreasing.
X is positively increasing and y is decreasing. And most important, I need your utmost attention. Real-time applicability of our numerical measures so far we have worked out.
I was going to ask you this correlation real-time applicability. You started it.
Okay. Now you observe here, friends, which are all the points I am referring. Exploratory data analysis, data pre-processing, and dimensionality reduction. Thereafter, friends, we are having the feature engineering. By seeing these things, what is the relationship between these four, friends? I have given answers. You have to frame the question actually.
These are
These are
classification.
Steps in data science process.
Data science process.
Okay, na? Right. Now you see, friends, what are all these steps? Of course, many times you have seen exploratory data analysis. What do you mean by this, friends? What do you mean by exploratory data analysis?
Fetching the data.
Some kind of descriptive statistics.
Yeah, the required one.
Understanding of the corresponding data. All these things comes under the category. Maybe describing the data or understanding the kind of the features available. All those things. Can someone help me, friends? What are the aspects we observed in the data pre-processing?
Missing values.
Very good. Missing value imputation. Next one is encoding techniques.
Encoding techniques.
Okay. Now, what do you mean by dimensional reduction, friends? Third one.
There is a new one.
No, we have already seen.
No, that guy is new to this. That's what he is claiming. The concept itself new. He's a wise man, Venkat. You could have observed by this time. He won't say I'm new to that. He says, yeah, this concept is new for us. Okay. Venkat, just to can you recollect?
More variables, something we can eliminate some of them that are not contributing.
Excellent. More variables are there. Then we have to apply some kind of the principal component analysis so as to get out of all the variables which are not really contributing. What do you mean by feature engineering, friends? Can someone give some example? Let me do this way. Suppose we are collecting the experience and as well as the skill and how many projects he has handled in the span of 1 year. Maybe our company is giving appraisal to us and we are having certain kind of the data with us. Now there is no values category. I mean, all these values are categorical. Maybe 2 years, 3 years, 4 years, 5 years. This is the junior level appraisal system. And skill set, maybe the members having how many skill set they are having, and how many projects they have worked. But unfortunately, to one of this guy, unfortunately there is a dot, and here also there is a dot. Now with the feature engineering, we have to find out the skill and as well as the number of projects he has involved. Okay, can someone give me the logical reasoning to find out without asking or without going back? Because that team is working very hard and they have to share by today 12 a.m. that sheet. Then only in this salary they are going to add our hike. Otherwise we have to wait up to next month. If it is the company work, we can take the chance, but if it is our appraisal, we cannot take chance. Okay, definitely we have to work. Then can someone help me? What is the wise decision we can take, and without any deviation, how do we compute this
Skip.
thing? What is that? Skip means
And you have to neglect.
But how do this guy is going to get the, because see, we are getting all in our team 2, 4, 5 experienced guys are getting high, but this guy is a victim then in that case. Any other? Okay, maybe that ignore one case I'm considering. Okay,
One and we have to see with
we have to see with the other members. Okay, and one more wise decision is, see, the same experience, maybe this kind of experience 3 is there, and you can pick up some other member who is having the same experience and who has joined on the same date. These are all hypothetical kind of thing. Feature engineering is nothing but, friends, what I am trying to say is, feature engineering is nothing but somehow you could not happy with the existing data. Maybe you can generate the new data with the existing values, then that is what you call the engineered feature. Or else let me give you this example. There is a chain of restaurants are there, friends. Chain of restaurants, what they are doing is they are making some kind of analysis on the habits of the users, assume that. And that particular restaurant, they collected the number of family members visited to that restaurant, and whether that those guys are having the smoking habit or not, and how much bill they have paid, and what is the tip amount they have given. Okay, now they want to do this analysis, like how much total bill they got and what percentage of the tip they have given to their waiters. This is the understanding. Now see here, friend, bill they are having and tip amount of also they're having. Now they want to compute the tip percentage. Okay, so then I need to add one more column here. I should give the tip percentage. So I have to compute by applying some kind of the formula. This is what you call the engineered feature. Okay, so such kind of aspects can be taken as the feature engineering. Hope you got the point, friends. Okay, now why I am referring these 4 points here is, have a look on this. Now one by one we'll see. The first point is, in case of the data pre-processing. In case of the data pre-processing. Now I am giving one scenario to you. The first scenario is, I need to handle the missing values. This is my first challenge. And I need to solve this challenge with the numerical measures so far we have discussed. Don't be in a hurry to answer, friends. Just to think through whatever the aspects we have covered in the stat models up to this. This is the 5th session, of course. Now I want to connect the dots which we have discussed in all these 5 sessions with the direct connectivity of our machine learning approach. So, like, everywhere we are trying to make use of the extension of this numerical measures usage with all these techniques. Now, out of those particular techniques, the first one is we are discussing about the data pre-processing. Now, what we are doing is, in case of imputing the missing values, okay, which are all the measures we can use? That is the first question I am asking. Second important thing is, if my data is having the outliers, and how do I detect that particular outliers? Okay, out of this data processing, I have given two options. Okay, that is as a team, we need to handle this particular missing value imputation. Now the numerical measures, let me write this side: mean, median, mode. These things we have seen. And thereafter, in the dispersion, we are having range, standard deviation, variance, percentile. Okay. Now, out of these particular thing, and one more thing, friends, we have seen covariance, correlation. Just now we have seen those aspects also. Now take your time and observe that out of the discussed numerical measures, which is the best one to handle the missing values. And one more thing.
Outlier detection is directly with the mean. You can directly get it from the mean. You can detect from the mean whether the particular data has outliers or not. Or you can also detect with the covariance also.
Covariance, how do we?
Because the covariance is actually, it is a mean. The outlier is directly linked with the mean. In the mean, you can clearly tell whether there is a
mean. If I am saying mean is prone to the outliers, then you are saying mean can be used to detect the outliers. There is a difference, na? See,
mean is directly proportional to the outlier.
That means.
So you can. That means in the mean you can identify whether that particular data has an outlier or not. The data set has an outlier or not. You can identify it now using mean.
Outlier, not identification, detection. Where is my outlier? How I have to detect that? Detection, maybe this one. This is the detection, not the identification. Suresh, yes, you are right. If I am taking the mean, I can say yes, my data is having outliers.
So you want to say that in the particular data set,
where that outlier is there, in which feature or which range or which row I am having the outlier, like that. If I am want to say, okay. Now, if you refer the first point, friends, actually imputing the missing value, what is your thought process, friends? How do I impute? Suppose in my given data, I am having certain missing values or null values.
Adding duplicates.
With the
duplicates. Replacing something.
Replacing something. That what is that something, Yogesh? Can you refer?
Replacing the required data, I think.
How do you identify it is having a missing value, Yogesh?
Missing value means null.
Now you know that there is a null there. Then you can say that, okay, I can put some other value instead of null.
Yeah, that is what null can be easily identified.
You need to identify whether that particular set has a null or not.
Yeah, Python provides direct function. NA with the NA, we can is NA, is null. That function we can find out.
When you identify the null, then what you said is you can put a different value or make it as a 0 or whatever it is.
Mean, median, or mode. Suppose if it is the salary, if it is the salary offered by Amazon, if it is salary offered by Infosys, then most commonly the mode you can bank on, or median, or sometimes, based on the situation, age, or some kind of the experience kind of values, maybe you can impute the missing value with mean, median, or mode, friends. Okay, based on the situation. And one more thing, see, in the session, actually maybe 10 to 12 members would be there, and either Suresh or Venkat or Yogesh, Lakshmi, and we are all flooding our ideas like anything. But in the project, it's not like that, friends. You are not given the sale of traveling. Okay, you have to discuss. Suppose if any null value is there and you want to take a chance of putting mean or median or mode, or even if you want to ignore also, it's not a single man decision, friends. See, maybe 2 or 3 times. And one more important thing, every 1 week or every 10 days sprint would be there, and there you need to discuss with your team mates and team manager and project leader. So we are getting this issue. Then can you have a look with SME, and based on his expertise also you should decide, because it's not a single man show or a single man decision. Because team in the typical data science team, you will be having the PhDs and the statistical masters and SMEs and the other members who are really involving in the process. So in that particular case, all you need to do is you have to discuss what exactly you are facing or what exactly you want to perform, and based on the agreement of all the members. And these particular codes you are keep on customizing and adding at a certain moment of time. If you change anything, it reflects to the entire aspects. So we should be very cautious. And of course, it's not like we are taking our own decisions and we are going to perform the reflection of that particular decision inside the project. Never happens, friends. It is not going to happen. Okay. Only the thing is just your suggestion. And before applying that particular suggestion to your Jupyter notebook or whichever, it has to traverse some members, and it has to clear certain rounds of measures. And then only at the moment you are applying this particular mean, median or mode, you will be reaching to a certain position of the conclusion. So you can without any problem, you can directly apply that particular formula in your node. So this is the flow, friends, actually. So just you can take one point and discuss with your teammates, and then based on the conclusion of your SME or whoever, then only you can raise your applicability of the same inside the Jupyter notebook. Okay, that's how the things happens in, especially in case of data pre-processing. Now you think through outlier detection. Mean, of course, I can say yes, of course, my data is having outliers. There we worked some other examples also, friends. How do I say in this particular in this range or in this particular aspect, I'm having the outliers. And just you go refer back, and there is a certain aspects you can bank on where you can say yes, this I'm having outlier. In this particular genre, I'm having the outlier. Just to observe here, friends, I'm writing the answer. Maybe you can easily connect the dots. What percentile is giving us, friends, actually?
Oh, the quarter, the 25%, the 58%.
Ah.
Okay, that particular location you are going. Oh, okay,
Yes.
okay.
Exactly.
I was actually thinking that only, but the example I was not getting.
Exactly.
I was evaluating each and everything.
Now you tell me, Suresh, compared with mean, whether percentile is the best option for.
It's the best option, 100%, because this is going with the location. At the 25th, at the 50th, and at the 75th. Exactly. So you can find out where exactly in which location there is
what is outlier, whether outlier present or not. Makes sense.
I was thinking if we can get say that I was just thinking if we can get the missing value from percentile, but I was not sure whether we can.
Missing value from percentile, do it really make sense, friends? Actually,
different.
I was just thinking earlier with percentile.
Yeah, actually, missing value we have to replace. We are not identification of missing value. There is a function, but identification of the outlier is very difficult in Python, friend. Python or R, because outlier in the sense that is also a value, but which is not at all belongs to this particular group. Maybe it is very tough to observe unless we are having some range of values. I don't know whether that value is outlier or not. But whereas missing value is not like that. The case of missing value is there is no value presented at that location, and you can easily grab that value from the number of records. That is what you call this missing value. So is null. With the help of is null functionality, you can get all the rows which are having the null values, and from that you can compensate with mean, median, or mode kind of the aspects. Whereas outlier is something different. That is exactly data. It's not a null value, friends. Observe here. Outlier is not a null value.
Outlier is a data. Yeah.
It's a data only. But that is not suitable to our context.
Yeah, you were telling about the GPA when it is like 13.5, obviously correct. When we do the percentile, we can easily find out where that value is like.
Exactly. Perfect. Okay. Now, one more important point I want to end here, which is very important, friends, because these are direct implications in our dimensionality reduction. Okay. First thing is, however, it is very easy from the available options. We can easily say that, okay, in case of my imputing the missing values, I can bank on mean, median, or mode. Whereas in case of my outlier, I can make use of the percentile. Now you observe here dimensionality reduction. Okay, what do you mean by dimensional reduction? Basically, from the available data set, okay, if I'm having 1,000 features and some 1 million records. Now maybe your interviewer may be asking, how do you reduce these 1,000 features to 100 or 50? What is the procedure you follow? Can you help me to observe? Definitely some of the dimensions are not going to help me. Then how do I regulate or how do I remove those particular features? Because I cannot play with all these 1,000 features, friends. The reason behind this is maybe the features are not contributing at all, or handling of or creating the model based on these particular features are definitely not a good idea. And one more important point, if you remember, curse of dimensionality. This is a basic issue in the genre of data science. Now you observe here, friends, how do I get into the features and how can I recommend my with my team? I have observed these points and I am defending that these features are not at all useful or not at all important to us. Then what is the point immediately comes to your mind? I'm giving the hint. In yesterday's session, I mean yesterday in the sense yesterday, the previous session and the current session, if you focus, then you can give the answer, friends.
By standard or
Standard deviation.
Suppose if I'm taking x1 and as well as x2, first discuss about these two aspects. Now the first scenario I am taking this one, friends. These two variables are highly correlated. Then do I need to have these two or one is enough, friends? Just you need to think.
One is like correlation.
One is enough. You have to think laterally, friends, because I could able to understand the x2 also by exploiting this x1. Even if I'm keeping x1, x2 also, my model is not at all getting any differentiation with nothing. No differentiation is there almost, because you know these two variables are highly correlated and my model is literally not getting any distinction between these two because they are highly correlated. If x1 is increasing, x2 is also increasing. X1 is decreasing, x2 is also decreasing. Then do I need to maintain these two or such kind of variables, friends?
No, one is enough.
Now the first option here is, have a look on this, friend. Very important statement. High correlation filter. What do you mean by high correlation filter, friends? Let me write this point here. If I'm talking about the high correlation filter, when two variables are highly correlated, two variables are highly correlated, then get rid of the two. Get rid of the two. Now immediately Suresh may ask, how much correlation, or is there any rule to consider? Because roughly if I'm saying highly correlated, how much correlation I need? Because in correlation discussion we have seen the R value, no? R
Yeah.
value there we have discussed negative, positive, 0.
0.
Now up to what extent I should consider the correlation? Okay, friends, here still there is no rule book to get rid. If those particular variables are nearing to 0.8 or 0.9 or something like that, then you can take the decision of removing one out of those two. Okay, because they are highly correlated. And of course, in my team also, just if you are at moment, we'll discuss maybe 0.8 or 0.9, then there is no need of parallelly maintaining these two features so as to embed in our model. This is how you can observe the dimensional reduction. The first point is the high correlation filter. And someone has given another answer, actually the standard deviation. Suppose, friends, on the other direction, just to think through, friends, if you are referencing the high correlation, that means these two variables are highly correlated. Exactly opposite to these things. Any point is coming to your picture, coming to your mind, like in one direction we are able to observe the highly correlated values, so that I need not go with all these multiple kind of the data.
Covariance.
Variance or variance. Let me write this thing. When you have very less variance.
Yeah. Because if X and Y values, if Y value is giving, the variance is giving low, then they both are getting correlated actually.
That's what I told. See, that is what, friends, see, every time while logically thinking, obviously the second point must be the extension or opposite to the first point. Generally you observe, friends, in any technical scenario. Like if I'm talking about the classes or objects, if I'm talking about the NumPy or Pandas or Matplotlib or Seaborn, first point, however, giving some insight to us based on the first point, especially in these kind of the techniques and traps which will follow in case of machine learning or data science scenario, there could be some kind of the extension or else some kind of the parallelism to the second aspect also. Now you observe here, friends, we are computing the variance value, and high variance means what actually?
High variance means the X and Y values are not matching. They are going your way.
Not matching. If they are not matching, do I need to keep in the model or not?
Obviously.
Obviously.
You have to keep the value.
Because the model should understand our model, understand our data. No? That means if I am taking x1, x2, x3, there is a high variance. I have to keep the values. Suppose if I am taking x1, x2, x3, and the variance between those three is very less, then what should I do, friends? There is no variance at all. We can get rid of that. So you observe here, friend, the measure I am following here is the variance, and most importantly, low variance filter. Friends, these are all not your basics. Basics means, let me give you this example. Maybe in your interview panel, you may be having
probably the mapping of this is really making a problem in the brain. Now, I think unless we do something on the system, because that is the reason why when you ask a question on this, I mean, I don't know about others. I'm not able to map.
Yeah,
So
yeah. Only one thing.
that is creating a problem actually.
Correct, correct. See, in case of the Python, even we don't think about this much, only just variance of x1 comma x2, that's all. It will give some value. Whether we need to keep or not, we have to decide. Don't worry about the coding, friend. That's what I'm repeating. These things, you know, like, how can I say, these are all the under the hood aspects, friends. If you are happy with your statistics, then you can proudly defend your results and you can showcase your internal observations, whatever the inference you got from the implementation of your machine learning and data science. You need not bother about the formulas or all, but at the moment I am asking, you should be in a position to tell, suppose how can I exploit the relationship between two variables, correlation, and how can I get rid of dimensionality reduction? I mean, suppose I'm having some different dimensions and I want to get out of some kind of the features, then how do I do that? Maybe with the low variance filter, but you may be thinking like, what exactly variance already we have seen. So when there is no variance, that means low variance filter says that there is no differentiation between two variables, then I can say I need not keep these kind of the aspects. This is what you call the low variance filter, which helps us to remove the columns when you have very less variance. That's what I'm going to write. So remove the features. Okay, remove the features when you have very less variance. Again, what is the benchmark? There is no hard or rule book is there, friends. Only the criteria here is you need to think through. Again, it is not a single man decision or the single man travel. Just you will be having equipped with your SMEs and your stats or your
This is basically an observation actually.
Observation. That's all. Observation is important, huh? Rather than.
Yeah, observation is really important. If your variance value is coming low, then we can think that yes, I think we need to remove some of the things. You have to go. You have to cross check. You have to put the check mark over there.
Initially, Yogesh has given one answer while I'm starting the dimensionality reduction. Can someone other than this thing, friends, any other idea is coming to you? Suppose I'm having more missing values, like I'm having some kind of the analysis, like previous company, maybe while recruiting or while taking our data, that HR would have missed our previous company details somehow, that out of the many records, okay, this previous company details were missed. And of course, you know, that too, we are compiling 15 years managers data in our own company. We are taking the members data, of course, who are having 15 years experience in our company only. Then do this previous company really matters, friends?
He told to remove the unnecessary data.
That's all. That's all. Now you see more missing values in the sense, ignore the values. Like initially our Yogesh has given this answer. Ignoring when it is possible is, friends, let me consolidate this thing. If a feature or if a variable has more than 30% of missing data or missing values, we generally ignore them. We means here data scientist. We generally ignore them. Then this is known as missing value filter. How many filters we have seen so far? First filter is, what is the first filter, friends? high correlation filter.
High correlation filter.
Second one, dear.
Then second one is the variance filter.
Low variance filter. That is what.
Low variance filter.
These things are very important. Low variance filter. Third one is the missing value filter. Very good.
But tell me one thing, Uma. If you're in a data set, if the values are missing, your normal tendency is to put more parameters to get those values.
More parameters in the sense, can you
In
elaborate?
an Oracle, suppose if I am not able to get my answer properly, I tend to put more parameters so that parameters may add up the things, to get my value. But suppose if I'm okay, if I have a more null values, missing values is a null value.
Yeah.
Okay.
No, let's complete because
I'm actually comparing my thought to what you have said.
Exactly, that is required, Suresh. Your experience should, if any ambiguity, then we can discuss. If it is okay, means we can consolidate the topic also. That's what my.
I missed because a missing value is a null value. So
null value.
Dealing with the null value is totally different. So I was actually, my thought was going like suppose in a data set, if I'm not able to get my answer, then I put more parameters. Where there are no null values. But if the null values are more, then missing value filter, yes.
Yeah, exactly. Yeah.
I'm mistaken.
Okay.
My thought was mistaken.
Yeah, no problem.
Where should I have to use the filters? These three?
Yeah. See, filter means what, friends? Basically, filter is nothing.
You're putting a barrier over there.
Barrier over there, and we are filtering the records actually. Filtering the records or filtering the dimensions or filtering the features, whichever. Now, high correlation filter, that means in what sense we are using here? If your features are having highly correlated, that means both the features are trying to convey the same story, so that we are not interested to learn multiple times. We means here our model is not at all getting any value out of those particular two correlated features. Then we can ignore one of the thing. We can easily remove that. That is a dimensional reduction technique. Second important thing is, of course, I'm having some kind of the features, and those features are not at all having any differentiation. Then I can say the low variance filter. Other important point is missing value filter. So maybe if I'm having some 30% less than 30% greater than data is not at all populated, then I can simply apply this missing value filter. So your dimensional reduction, we can make use of this high correlation filter by observing the correlation between the values, and low variance filter just by applying the variance kind of thing. And if I'm having more missing values, then I can bank on this missing value filter.
And there is a question here.
Yeah, please go ahead.
The 2 and 3, there is direct things you are putting. Missing value perfectly, because you are saying that 30%, it is a gunshot, but there is a problem and you put a missing value filter. And low variance, that when you extend by values you are observing, it clearly shows the variance is low, means there is a problem. Variance is high, means there is no problem.
Yeah.
Okay. But in correlation, how do you catch up the things? Now, you're saying that in my model, suppose I'm putting S1, S2, S3 till X10, and I'm applying to the model is going off. Now, how do I detect that? Which one is that? Whether it is X2, whether it is X5, whether it is X7, how to find out that? Because this is really tricky over here in correlation.
Yeah, exactly. Now, friends, can someone answer this question? Between how many features we are applying the correlation? Did I say X1 to Xn? Can I apply all n variables I can give the input for the correlation formula, friends, or else we have to go through one by one?
Correlation clearly says that there should be relation between some things.
That
There is a boundary.
Boundary.
There is a particular elements will be
And
there.
one more.
Not like unlimited.
Yeah.
You cannot compare all things in one time.
Can we submit Can we submit all the features to this formula?
Oh, it's impossible. Correlation doesn't explain that.
Only we have to
Only you have to go individually one by one.
Then you reframe your question in that case. Then
no,
how do
no reframe? It's zero. I'm taking back. Because yeah, when it is going with a single one-to-one, then definitely you will be observing what is the output of that. And
one-on-one we have to go, Suresh, because see, we are taking a violent decision. Actually, violent in the sense we are removing that dimension. See, we are not playing with the dimension. In fact, we are unfit. We are saying that you are no more with our model. Then we have to spend at least some reasonable time. See, to prove someone as which is not fit for the current situation, we have to spend some reasonable amount of the time. Then only we can say, yeah, this guy is not at all suitable. Simply by seeing or by talking, if I'm saying, no one believe me. Similarly, in our statistics or in our machine learning kind of the decisions also, you should be having valid evidence, friends. Just you observe that. You go to your office and that day just you open your model, and you are not, by the end of the day, you are not going to complete the task. Never. It takes some months to years also. Together on the same Jupyter notebook and same kind of the notebook, you will be spending some months together. Reason behind this is it's not direct implication or direct implementation. You have to take the consent of all the members, and you have to float your ideas, and then only you are allowed to implement or run through the appropriate aspects. Okay, so don't worry, definitely members would be there.
Yeah, Uma, I'm stupid here, because when you go from x1 to xn,
no, if I'm don't say like that, because see, maybe
see, this is a basic thing which I've lost is when I'm putting x1 to xn in a loop and try to get value, definitely each is putting there and giving a value.
Definitely you should ask. That I always encourage. No matter whether that is a silly question or intellectual question, and it's perfectly all right, Suresh, because maybe your question would be help to someone else who is in the call. Definitely, I am not against it. You can.
When I know the looping concept, you should be able to understand.
It's perfectly all right, Suresh, because even you are asking silly questions also, because that somehow it is maybe after some time you can say that, oh, how did I miss this, maybe, but some people definitely it is going to help, friends, and in a way it's a kind of summary. It's a kind of summary.
Because somewhere I'm not able to map what you have told.
That's what. Exactly. That's what, friends. Here, the trick behind this learning of stat and this kind of thing is preparation. And just you think through after completion of the session, and you open the class shell. No need to go with the video also in the first run. Just to spend 5 to 10 minutes, friends. That's what I always keep this the word, like, so just you should reverse engineer here. So let me pull down this key takeaways. Can someone help me? What is the first point we have discussed? There are certain issues. Second one is the correlation. Very good. Solution to covariance issues. Next, we jumped into real-time applicability. This real-time applicability, initially we started our discussion with the missing value imputation. Then, friends, what we have discussed?
Correlation filters.
That filter, what is the initial point of that filter? Dimensionality reduction. In case of the missing value filter, what is our standpoint? What is the solution we have taken? Imputing with the mean, median, or mode. In the dimensional reduction, what is the three aspects we have considered? One is the
correlation.
Correlation. Just I'm hinting. And second is
Low
the
variance.
variance filter. Third is the missing value filter. Right. And you go back and verify whatever the aspects we have considered, and you could able to connect it out. But still, if you are facing any difficulty of understanding, definitely we will discuss in the next session. Okay, that's all, guys. And in the next session, okay, just I'm going to introduce you the aspects of the probability, which is again a lot of fun would be there. Definitely fun. Definitely fun means discussion. So it's not a smooth sailing, friends. Actually, I can say.
No. Many quarrels you will fight between the thought process.
Exactly, that is required.
Till now, we have bent our neck in front of you because this is the concept. Now it is not like that. It is a direct Mahabharata war.
Okay, guys,
but that's good, we will try to understand how we need to do it in the real time.
Yeah, really. Because see, after telling all these things, if I'm not pulling that real-time scenarios and where we are making use of these numerical measures, is a completely mess, na? So this guy is giving some formulas and he's not connecting the dots.
It will go out of the way. You'll be out.
That's what I'm saying. See, now only the thing is, in the session you may feel some kind of the disconnect or difficulty. Just you follow this approach. Just you go back and see the class shell, and you try to recollect everything whatever we have
Actually, this is not something we're not able to understand. We are understanding, but what happens is because the stats is totally depend on numbers. That numbering, when you are getting that number into the brain and try to correlate, that is not happening actually.
Our brain won't accept numbers, na? That is the problem. Our brain accepts only scenarios, examples, and all. If I'm saying you the formula, but one good news is, Suresh, for all of us, you need not remember the formulas only, but you should remember at least the boundaries, as our Yogesh told, na? Like correlation -1 to 1. Covariance, covariance, there is no boundary. Units are also not in our hands. Like those key points we have to refer, Suresh. Okay, because based on that thing, entire things are revolving around. Okay, that is the most important concept, right? That's all, guys. Hope you enjoyed the session. And however, tomorrow onwards, our ride is a bit changing. We are not going in the same Volvo bus, and we are taking some other travel plan, auto or something. So that be careful, and we have to adjust little bit until we reach to. But the destination is nearby only. Okay, only 2 or 3 sessions we are going to dedicate for this probability. I'm not creating any chaos. Only the thing is I'm just informing you. Okay, right? Because the mindset you need to change. Like it's not a probability itself is assumption actually. Probability, the probability, that is what more imagination, more assumptions would be there. Prepare for more complex topics. Okay, thank you very much. That's all, guys. Yeah.